Next up is Charles Garris. Charles is the VP of Product Development, Engineering, and Technical Services at the CMD Corporation. It's another one of these corporations that makes a machine that makes things that you use every day. And Charles is the leader in design and manufacture of high-performance film, CMD actually, Charles is too though, is the leader in the design and manufacture of high-performing film converting equipment for plastic converting and flexible packaging industry. I just knew that was going to be a trip up for me. All right, let's take a little closer look at CMD. Please join me in welcoming Charles Garris.
Hello, everybody. So today I'm going to talk to you just for a few minutes about CMD, and something that I like to say is our Likable Solutions. It's an unusual term, and I'm going to explain that in a little bit. But first, just to let you know, I'm going to be talking a little bit about me, a little bit about CMD. CMD's mantra: the problem with our problem solving, the secret sauce, and some tips. So I'm a mechanical engineer by education, and I've had a career. I've been very lucky. I've been in the consumer electronics space for a little while, in the appliance industry, controls, electromechanical controls, lighting, home improvement, and currently in the industrial machinery world. I am a user, or had been a user, of SolidWorks, at the time Cosmos finite element analysis, and the Stratasys FDM 3D printing since about 1995. I was really lucky at this presentation because I never thought I'd be presenting right before Scott, and I spoke to him for a few minutes, and the fact is Scott is directly responsible for a lot of my personal successes in my career. It turns out that I was, again, very fortunate. When I worked in these other industries, I was able to come up with some products with my friends, my colleagues, and we patented them. And a lot of them were successes. We received a number of awards at the consumer electronics shows, at different do-it-yourself industry shows. And it's 100% directly relatable to the tools that were available to me and my colleagues at the time. You know, had we not been able to design and model and then demonstrate to people with the 3D modeling or with the 3D printing, we would never have been able to convince them what an awesome solution we had at the time. So I really get excited about technology, advancement, and the linkage between all of these industries and all of these products and capabilities that we have today. It happens, another little tidbit about me, it happens that I am the son of 4 generations prior of dentists. You'll see why that matters in a few minutes. Another little tidbit, I'm extremely squeamish about blood and guts, which is exactly why I'm not the 5th generation of dentist. And then one of my hobbies, it's not so far of an offshoot, I really, really like looking at the history and the advancement of technology, but also of dental instruments. That's not the only thing, but dental instruments help, because of the family connection and all of the tools and stories that I have in my family, it helps me appreciate a lot of this stuff. These are just a few snippets of some tools I have in my basement. I've got a whole bunch of tools. If any of you actually have an interest in this stuff, come see me afterward and we'll chat about it. But what you see there is the first set of tools from the 1800s were my great-great-grandfathers. And they used ivory handles at the time. They were gold-plated, and as you can see, they've corroded over time. The way they used to sterilize them was typically with alcohol. Then into the 1900s, you saw a lot of tools that were made very similar looking to the old ivory handle tools, but they used aluminum and steel, and those were typically sterilized at that point with steam. And then in the 2000s, you've got pretty much all pure stainless steel tools. And they've evolved a little bit more. They're a little bit more cost effective. You don't see the big handles anymore. And these are sterilized, I think, in an autoclave oven setup now. The drills have evolved over time also. This isn't that long ago. I mean, there was a time in my great-grandfather's time when there were no power drills. And then in the time of Thomas Edison, they started using belt-driven tools. I have one here if any of you want to stop by afterward and look at it. If any of you recognize the noise, bzz, bzz, we all hate it. And this is one of the reasons I'm talking about this. This is something that I think we can all kind of relate to. And one thing about these is why don't they use them quite like this anymore? One of the advancements in the technology was that they started using water and miniature turbines inside this. And not only did the water allow the turbine to go a lot faster, which made the experience, the negative aspect of the experience, shorter in duration for us, but it also sprayed water into your tooth, which, just like any other mechanical part that we might all work on, started to cool the tooth. So even with a Novocaine, it would have been very uncomfortable to feel that heat generating while the dentist was drilling you with this. Nowadays, they have other things. I was just learning at the table from one of my colleagues that a friend of his had a cavity filled, and the way they operated was with a laser, an intermittent laser technology that was making a painless situation out of it. It's just amazing the way the technology is evolving. So what's the point of all of this? Why am I talking about dentistry, and what does that have to do with me? The reason is I believe wholeheartedly that it inspires hope. It's history. If you look at the history, it's evidence that solving problems, little problems, all along the way actually matters. And the best thing about it is how the advancement of technology, I personally think, is incredibly exciting. Incredibly exciting. And the reason it's exciting is anything that any one of us do can matter. It may not always seem like it. You know, it can be such an incremental little advancement. And in time, what you can see with the history of things is things evolve and things change. And as that happens, we learn that the little contributions that any of us have made mattered. Okay, a little about CMD. So we don't make trash bags. Okay, what do you do? We make the machines that make trash bags. Just like in the show, How's That Made? We're one of the least well-known brand names in America, but our machines produce almost every type of trash bag in North America, which means every single one of you and just about everybody that you know or are about to meet or have known use trash bags that were made on CMD trash bag making machinery. We also happen to make a lot of machines that make other things, like pouches. You see your dog food now comes in a lot of pouches. Trail mix comes in pouches. Nowadays, when you go to the dentist office, they break out the instruments, and they often come out of pouches. Hopefully, you don't have to go to the surgeon, but again, they wheel out a cart, they crack open a sterilized pouch, and in there is the instrument. Well, we don't make the instruments, and we don't do the process, but we make the pouches possible that that industry uses. This is an example of a tamper-evident mailer. Banks use these. A lot of institutions use these. And again, just a little plastic baggie, but it turns out it's a pretty complicated thing to assemble. Everything is flexible, and it doesn't want to collaborate with you. Everybody wants it cheap, so it still has to be processed really fast. The thing has to work. You can't have one of these spring open and have people wondering, hey, what happened to my $2 million? So we also happen to make machinery that makes compressed natural gas refueling possible. You might say, what the heck's the difference? Why are they doing that? Turns out from an industrial machinery standpoint, there's a lot of symbiotic infrastructure needed to make this possible. But when you drive along the highway and you see a gas station and it says diesel, gasoline, you might also see CNG. And usually, if you pay really close attention, behind the gas station, you'll find a fenced-in area where this is the type of equipment back there. And a lot of times, it's CMD equipment. So what's our mantra? Listen to our customers, learn new ways to solve problems, and lead advancements in technology. This is probably why I joined CMD. There's philosophical alignment between me personally and the company's mantra. We happen to have won Best Places to Work in the entire plastics industry 3 years in a row now. We're very fortunate. And the way the survey works is employees vote in, and it's done anonymously. Somebody in some organization rounds up all of the results of companies across the United States. And it turned out that we are in the top 10 best places to work, according to our own employees, and a number of other things that they measure people by. So you might ask, why? Well, I have a hypothesis, being an engineer, of course. One of our engineers said, CMD invests in technology tools to maximize my personal potential to innovate. So what's the connection here? Best places to work, this hypothesis about investing in technology. I believe that it's because of that I'm able to attract, motivate, and retain some of the best people out there. I believe that it helps us build trust. And I don't just mean with external customers, I mean with internal customers. An engineering manager receives product from his engineer. He wants to be able to trust that the engineer is not only competent, but is producing things that are going to advance the company. He's making good decisions, and he's using the best tools available. So this investment in technology earns repeat business, internally and externally. So what are some examples of tools that we've invested in? Well, we've invested in SolidWorks, and not just the basic package, the granddaddy of the packages. Finite element analysis came along with it. 3D printing, we've bought a lot of 3D printed parts. As a company, we're learning how to integrate it into the process of machinery development. And we use a number of other tools of this vein. So when we put them to work, what do some of our products look like? So this is a picture of some of our machinery. And what you can see is really, really complex assemblies. Back in '95, when I started using SolidWorks 95, I would never, ever have dreamt of putting something that crazy together. Ever. The computers were way too slow. The software would have crashed. It wouldn't have worked. It would have been a snail's pace. And today, we can actually do something that complex on our CAD stations. And believe me, when you have over 10,000 unique parts in an assembly, it enables the company to engage different functional areas in brainstorming, in philosophical debate about approaches, about the process. It stitches together electrical, mechanical, manufacturing, marketing, sales, all facets of the company. When you physically make it, this is what that thing looks like. And when you walk around it, you realize, wow, this thing was really complicated. How in the world did actually so few people collaborate and make something this complex that actually works? It's really astonishing. If I worked at Ford, I've done work with Ford before, and I can tell you that personally, when I've gone in there and I've walked around the building, I was taken aback. 4 or 5-story building, they had electric escalators, and the whole building that I was in was one division of one group of one subspecialty of engineers. I said, oh, okay, no wonder they can design a car. They got this kind of focus on a dashboard. But when you go to CMD, in contrast, we've got, 30 engineers, 50 engineers, depending on the day and the nature of our capital cycle. It's nothing compared to a Ford. Yet the quantity of parts and the complexity of what's being accomplished is on the scale of Ford. It doesn't have the reliability, it doesn't have a lot of the testing and the standards of the automotive industry. They are different. But the fact that a small company could even contemplate taking on a project this complex is only possible because of the advancements in technologies that we live with today. We use, as I said, finite element analysis. These are just some parts. We use it for thermal analysis. We use it for flow analysis in our compressed natural gas. We use it for vibration analysis. You couldn't have a natural gas station vibrate off of the plate and wander off into the street, people would freak out. There's all sorts of situations that are pretty scary if you don't do them right. And this finite element analysis not only makes sure that we're doing the right things, but it keeps us out of trouble. This is one of our machines working in action. And I can tell you that it's extremely rewarding at the very end of a very extensive CAD and engineering cycle to see something like that making that noise. We did not design it for acoustic pleasure, but it still is a pleasure to hear it after you have that many people put something that complex together. Okay, so I've shown you all of this good stuff, but there is a problem with our problem solving. And I think it's a problem that every individual in this room has at some point in their career. It's a problem that every company across America that I've interacted with happens to have. And it goes something like this. The customer has some unmet need. Again, the customer could be an internal customer, could be an external customer. So if you go to CMD, we listen. We try to identify the problem. Each company has their variant of problem identification. So then, how do I get to the specific problem? Again, depending on where you work, and depending on what your background is, you might have different approaches to it. We heard David yesterday talk about a disciplined process. We heard Scott today talk about an incubator and a creative idea generation funnel. Some people say go to Six Sigma. Other people say go to lean manufacturing. Depends on your environment, depends on the situation, right? But ultimately, you research and you pull every trick out of your hat. So finally, you understand the problem. And you say to yourself, all right, what are we? We're professional problem solvers. So we're going to put on our problem-solving hat, and we're going to solve it. So you create a solution. And I'm going to oversimplify it. It's that easy. We create a solution. Boom. And how did I get to that solution? Again, somebody happens to ask, you say, oh, simple. I brainstormed, I researched, I collaborated. Some people would say, oh, inspiration and perspiration. And then other people would say, oh, I use tools like SolidWorks, finite element analysis. Oh, I used MATLAB. I'm very mathematically inclined. I use 3D printing because then I could look at things, and I'm very visual and tactile. So the engineer in us says, all right, I presented a great solution to you. Sold? This could be to your boss. You give your boss the solution, you say, here, look, I understood the problem, and I spent hours thinking about this. I mean, even when I put this down at work and I go home, I'm taking a shower and I'm thinking about that problem. Finally, you present the solution and you're wondering if it's sold. So you're not only looking for a solid yes, you're looking at the body language of the person, whether you realize it or not. Or you're waiting to hear whether your salesperson told the customer something and how did that customer react, right? And you get this weird, maybe yes, maybe no. What? How many times does that happen to any one of us? Like, what? Don't they understand all of the work that I put into this? Don't they understand this thing solves their problem? Why isn't it just, yeah, woo, yeah? Where is that? So what I'm going to say is it's not good enough to just solve a problem today. Society expects more. The example in dentistry is pain numbing medicine. You can't just fix a guy's cavity without that. Here's the thing. The customer has to like the solution. Just put really simply, there's a lot of different ways of saying the same thing, but at the end of the day, it's that simple. You have to solve a problem, and the customer has to like it. And you might ask yourself, well, what do you mean by that, Charles? Like it. It's that mushy crap. Let the marketers put spin on it. Let the salespeople polish it. This thing solves the problem. It speaks for itself. They had a problem, and I fixed it. It's not enough. It's not enough anymore. People have to like the solution. So let's give you an example. So my boss comes to me, he says, hey, this product is warping. And I look at it and I say to myself, this looks like a nonlinear thermal stress. but I don't have the tools to diagnose it correctly, let alone then solve it. Well, back in the day, what I would have done is, kind of old school, I would have fabricated maybe 3 prototypes. I would have sent it to the laboratory. I mean, there's a lot of costs. I would have had the fab guys, the model makers. We would have made pretty complex things. We would have instrumented it up. Maybe we used LabVIEW when it finally became available, thermocouples, strain gauges, force transducers, you name it. Every trick I knew from lab. But that's really, really expensive, and most companies aren't funding that anymore. So what other trick do I have? I could buy SolidWorks Simulation Professional. That's the granddaddy package I told you that we bought. And it turns out I also need time. It's not simple enough to say, oh yeah, sure, buy me the package, I'll knock something out, I'll have an answer for you in 2 hours. This is where engineering managers in the room have to work hard to create space for the people who are actually utilizing these tools. They need time, they need focus, and they need to be able to model things up correctly, because it's very easy to model them up wrong for those who have used them. So I have a solution. It's this simple. Just buy SolidWorks. And what you find is, I get to the CFO and he says, are you kidding me? This isn't $500 a pop software. This is 10 grand with computers and everything, a workstation. How in the world are we going to afford that? Are you crazy? The problem is, if I just bring the solution to him, he doesn't like the solution. I have to educate him on the solution. I have to make him feel good that this is a lower cost total way of solving the problem. It's not about these prototypes and months in laboratories. This is actually a great solution. But if I don't invest the time to teach the CEFO this, if I don't invest the time to help somebody understand the value in something, if I don't present it well, they're not likely to like the solution. So I ask you, if any of you in the audience have ever felt like you're pulling teeth at work to get the solution approved, right? How many times do you feel like that's the expression? Now, the one advantage I have over probably most of you in the audience is I can actually pull up a visual aid. I take it to work. When I was a cocky kid, I used to go in there and be like, dude, we used to say that then. I don't know if they still do. Do I need to use this? You know, I thought the solution spoke for itself, but it doesn't. So I want to walk you through a very simple but very, I think, helpful way of looking at this. I've got on one axis, does the customer like the solution? And on the other axis, I have, does it solve the customer's problem? If the answer is no to both, then the outcome is very obvious. There ain't nobody who's going to be happy. And what kills me is when I see something that's got all fizz and pop, and it doesn't solve anything. I think everybody in this room, being technically inclined understands that you've seen products that don't really solve a problem. It's all fizz and pop. And then you get the smiley face missing a tooth. For a while there's somebody who's happy, and you say to yourself, what the heck? Doesn't he realize he's missing a tooth? It doesn't solve a problem. That's not a very good thing. I'm not proposing that. The flip side of it is the illustration I showed you a minute ago with a CFO. You got a cavity, and yep, I can solve it. I'll put a filling in. But guess what? You ain't going to be happy with the way I'm going about it. The thing to strive for as individuals and as companies is to find both a way of solving the problem and making sure that the customer likes the solution. So don't just solve problems. Make sure they like the solution. I want to make one more connection here. So investing in technology, how does that foster trust? I'm going to take a little chapter out of that guy, Franklin Covey. He says that trust is equal to character plus competence, where character is something like the person is honest, and competence is the person has skills. You can just imagine, if you go to a carpenter who's punctual, honest, doesn't overcharge you, and he puts in the door, and the door looks like this, you're probably not going to trust him to do another job on your house. That's the skill and the competence part. And that's the tie to technology. The technology and your continual education, continuous learning, is the tool that you have at your disposal to maintain your competence level. And I can tell you one thing personally. Don't wait for companies to invest in you. Invest in yourselves. If you went through college 20 years ago, 30 years ago, don't just stop there. Continue to invest in your continuous learning, because you will help maintain trust between you and your boss, you and your customers, on the competence dimension. And trust me, trust allows people to like solutions and like products. You have a product that has failed on you, you won't trust that company again. If that person disappointed you, he didn't do what he said, he couldn't do what you asked for, you won't trust that person with your job, with your money, with your career. Now, trust doesn't enable like. There's people I trust, and I might not really like them too much, but I'll tell you what, I can trust them. And if they were a little nicer, I might even like them. So I just happened to go to the website of Stratasys. We didn't collaborate on this, so this is the first time he's seeing this. And I was just tickled to death. Here's a way that they're using 3D printing for the dental industry. And they can make retainers nowadays with this. They send this out to labs. Not everybody's adopted this technology, I bet, but they're probably starting to. And Stratasys is probably working to not only show that they've solved a new problem, but they're going through awareness building and building relationships and trying to demonstrate that you can like this you can not only solve a problem, but like this solution if you're in that dental industry. So how does CMD accomplish likable solutions? It's very complicated, but at the end of the story, what you'd realize is that a little company in Appleton, Wisconsin that is not very global or multi-ethnic actually has accomplished installations of our machinery in over 40 countries around the world. And that doesn't happen simply by solving problems. So a couple little tips for you. Market your solutions. Show your enthusiasm, your personal enthusiasm about the thing that you do. Be convincing and teach others. Use visual aids. Remember that looks matter despite however much any of us don't think that they should. They do. They influence people's perceptions. And sell your ideas, because you will accelerate your ability to advance technology. Cell phones are a good example. What's the difference between a Kyocera, a GE, a LG, a Samsung, iPhone? They all solve pretty much the same problem now. You know, the question gets down to which one do you like more and why? I know what phone I don't like. I don't like the screensavers on some of these. So I invite you guys to link in with me. Just make sure you say where you went so I don't think you're a crazy person. And stop by and we can chat some more. I would love to learn a little bit more about your businesses. And if you don't mind, I'd like to give a big round of applause to GSC, because this whole event blew my socks off. It's my first time attending, and I couldn't believe what a splendid job the team did.